Imagine you're in a huge park. On the opposite side is something you want to reach. Normally, you'd have to walk all the way across. Every step, every meter, every second of the journey. But what if there were a secret tunnel? A tunnel that connected your side of the park directly to the other side. No long trip, no crossing the distance in between. You step in one end and emerge somewhere else entirely. Congratulations! You've just imagined the basic idea behind a wormhole. At least, sort of. Wormholes are one of the strangest concepts in modern physics. They are often described as shortcuts through space, a way to connect places that should be unimaginably far apart. But here's the question: do wormholes actually exist? And if they do, could anything survive traveling through one? To understand a wormhole, imagine an ant walking across a sheet of paper. If the ant wants to reach the opposite side, it must walk the entire distance. Now, imagine folding the paper so both ends touch. The ant could suddenly cross the gap through a shortcut. That's the basic idea behind a wormhole. In physics, a wormhole is a hypothetical tunnel connecting two distant regions of space-time. The concept comes from Einstein's theory of general relativity. Mathematically, certain solutions to Einstein's equations appear to allow such shortcuts. The important word here is hypothetical. Scientists have equations that describe wormholes. They do not have evidence that one exists. This is where things get frustrating and fascinating. Wormholes are allowed by some mathematical models, but mathematics isn't proof. Physics is full of things that can exist on paper but never appear in nature. Right now, nobody has observed a wormhole. No telescope has found one. No spacecraft has flown through one. No experiment has confirmed one. So, if someone tells you wormholes definitely exist, they are getting ahead of the evidence. The honest scientific answer is, we don't know. And that's what makes wormholes so intriguing. They're not fantasy, but they're not established reality either. They're somewhere in between. Even if wormholes exist, another problem appears. Most theoretical wormholes would be unstable, very unstable. According to many calculations, they would collapse almost instantly, faster than anything could travel through them. Some physicists have proposed that a special form of matter with unusual properties, sometimes called exotic matter, might keep a wormhole open. The problem? Nobody knows whether enough of this material exists in nature. So, we're faced with two mysteries. First, do wormholes exist? And second, if they do exist, can they stay open long enough to be useful? Scientists currently don't know the answer to either question. Now, let's talk about the reason everyone loves wormholes. Travel. Imagine visiting another galaxy. Normally, that would take millions of years. Even light needs enormous amounts of time to cross the cosmos. A wormhole, in theory, could provide a shortcut. You wouldn't travel faster than light through space. Instead, you'd take a shorter route through the structure of space-time itself. Think of it like driving across a mountain. You could go over the mountain or through a tunnel. The tunnel doesn't make your car faster, it makes the journey shorter. That's why wormholes show up in so many science fiction stories. They're one of the few scientifically inspired ideas that might allow practical interstellar travel, at least in theory. Most physicists consider wormholes an open question. General relativity permits certain wormhole solutions, but nobody knows whether nature actually creates them. And even if nature does create them, nobody knows whether they can remain stable. Many researchers view wormholes as useful theoretical tools. They help scientists explore the limits of gravity, space, and time. But until evidence appears, wormholes remain speculative. Interesting, possible, but unproven. So, if you had to explain wormholes to your dog, you might say this. Imagine a secret tunnel connecting two distant places. Physics suggests such tunnels might be possible. Scientists can describe them mathematically, but nobody has ever found one. Nobody has ever traveled through one. And nobody knows whether they are physically possible in the real universe. Which means wormholes occupy a strange place. They're not science fiction, they're not science fact, they're science, maybe. And sometimes the most fascinating ideas in science are the ones that live in that uncertain space. Because every once in a while, something that starts as a crazy idea turns out to be real. The question is, will wormholes be one of them? For now, nobody knows. Not even your dog.